Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Green Booklet, Practice Test 1, specifically Unit 29, questions 92 and 93. And in this unit, we're told calcium fluoride is added to water to give a saturated solution, and we're also given information about the KSP, which is a solubility product constant. So the greater the KSP value, the greater the solubility of the substance. And the molecule of low solubility forms precipitate and has a low KSP value. So this information is more relevant for question 93, but what we're going to focus on is question 92. So in question 92, we're told that fluoride ion is a weak base and its conjugate base, it's the conjugate base of the weak acid hydrogen fluoride. And the question is asking, CaF2 is more soluble in what solution? Now I've written here neutral solution. So in the stimulus, we're told that calcium fluoride in a neutral solution produces this reaction. So we know that's our baseline. So straight away, we know it's either going to be acidic. The answer has to be acidic or basic, because if a neutral solution is going to produce a very saturated solution, we want something that's going to reduce the saturation. We want something that's going to make it more soluble. So that's why it's less likely the answer is going to be neutral. So we can say B is incorrect just off the bat. So it's either going to be an acidic or a basic solution that's going to make our calcium fluoride more soluble. So that's what we're trying to do. We're trying to shift this reaction to the right, because if we shift the reaction to the right, we're going to have less precipitate, so less calcium fluoride solid, and we're going to have more in the solution. It's going to be more soluble, because that's what the question is asking, which solution is going to be more soluble. So let's think about it. Let's say if we add a base. So if we're going to add a base to this system, so let's say we add, because we're told in the stimulus that fluoride ions are a very weak base. So let's add the fluoride ions. So if we add more fluoride ions, so we're going to add more fluoride ions, what's going to happen is that we're going to have too much of the items on this side. And what that means is we have to shift the reaction to the left, because remember it's equilibrium, Le Chatelier's principle. So it's going to shift to the left for equilibrium, which means we're going to produce more calcium fluoride solid, which means we're going to produce more we're going to produce more saturated solution and more precipitate. So therefore, if you're going to add the weak base, I mean, the same if you're going to add a strong base, it's the same principle. You're going to push the reaction to the left, we're going to produce more solid, and it's going to be more precipitate. However, if we add an acidic solution where we've got protons, the fluoride ion, so is going to combine with the proton to form remember it's a weak acid hydrogen fluoride, and because it's a weak acid, it's not going to ionize, so it's just going to stay there in solution. It's not going to do much. So what that means is if we just have lots and lots of hydrogen fluoride in solution, we're going to lose. So we're going to lose our fluoride. And because of Le Chatelier's principle and because of equilibrium, we have to shift the equation to the right so that we can produce more fluoride ions, because we've lost the fluoride ions because they're forming hydrogen fluoride in the acidic solution. Which means if we're shifting the equation to the right, calcium fluoride number is going down. So we're going to have less precipitate and we're going to have a more soluble solution. So that's why 92 answer can't be C or D. The answer is going to be A. So now if we move on to question 93, which we alluded to in the intro, it's asking us what will be the order of precipitation based on these compounds with their KSP values. Remember from the outset we said the greater KSP value, the greater the solubility of the substance. Now what we're asked is to find which will give the greatest precipitation, so the order of precipitation. So obviously the KSP value that's the lowest is going to have the highest, is going to produce the most precipitate. So if we think about it like that, so let's just write it quickly. So KSP high equals high solubility. KSP low equals high precipitate. So that means if we look at our graph, we're trying to find out which has the highest precipitate or the order of precipitate. So we've got so reading, so if you're going to read scientific notation, a -6, a -9, and a -8, we know that the one of the greatest zeros is going to be the smallest number. So it's going to be -9. So it goes SRF2, then it's going to go, so it's going to be like that, to magnesia F2. It's going to be greater than the BAF2. So you can see, therefore, the answer is going to have to say SRF2, then MGF2, then BAF2. So the answer for 93 has to be C. And I mean, you can ensure other things just by reading this. So if SRF2 is going to form the greatest precipitate, that means BAF2 is going to be the most soluble. So you can go back and forth with these. So I mean, if you do have any more questions about this unit, you can post them in the comment section below, or you can contact us directly. We'd love to help you. Chemistry, again, is our bread and butter. Thanks for your time. Bye now.